Ladies and gentlemen, a good afternoon to all of you. A warm welcome to our first session here. The program makers have dedicated it to urban drainage, retrofits and rethinking. And retrofitting, of course, is a very important issue in our aging cities. And retrofitting without rethinking is a cost mistake. I think we all agree to that. So different functional, economical and environmental criteria must be considered, as well as sociological and urban design aspects when thinking for the cities of the future. Cities are living, so they will change, of course. It's a very complex case, very case-specific in often times, and you will be aware that there is no optimal solution for every case, but a lot of very, very good solutions. We will hear some of those solutions, and I'm very proud to have 6 presenters here with their new and fresh ideas, which will give us hints for the cities of the future. Okay, as first speaker, I would like to introduce Jeroen Kluck from Amsterdam University of Applied Sciences. He has a working group on climate change cities and the research on those topics, and he will present his paper. I will not announce the titles of the papers because that's your turn. Please.
Okay, thank you, Matthias. Okay, welcome everybody. I'm happy that you're here. I'm thrilled that I can present here, the first one in the afternoon. I'm looking into a black hole, more or less, but okay, I hope you're sitting here. Yes, you're there. I will be talking about climate-proof retrofitting of urban areas, and I will try to show you that, at least in the Netherlands, this can be done for the same cost as standard retrofitting. This is really research which we have been doing at the Amsterdam University of Applied Sciences, and together with also the Hansa University of Applied Sciences and some other companies. So some people also written there. And I present a Dutch book. That's this one. It's free, it's on the internet, and you can afterwards come to me to get a copy digitally. I will be talking about urban pluvial flooding. So sometimes it rains so hard that the rainfall doesn't fit at all into the sewer system, so then the roads are also waterways. And how do we design the city in such a way that this doesn't really cause real problems like water in stations, but also in houses and everything. So these are some examples of Amsterdam, but okay, every city has some of examples like this. So, in the Netherlands, we already some years think about climate change and how we should deal with this, and now the authorities defined a Dutch goal that every reconstruction should be climate resilient, and that we should start in the year 2020. And also think that every street will be reconstructed once in 30 years. This is a huge opportunity just to retrofit every street before 2050 in a climate-proof way. So this is something we want to do, and of course this gives rise to some questions. For example, we need practical examples. How are you doing this? And of course we want to know how much does this cost, and do we really want it? So, to help with this, that's what I make this book for, and okay, help you with the title. The climate also fits in your streets. So we show that by doing simple solutions, a heavy rainfall can also be stored in the street or discharged in the street without big problems. Now, we started making this book, and we are at the University of Applied Sciences to help the municipalities on starting moving, because many municipalities say, yeah, climate change, now there are so many other important things, why should we bother now? And other things are more important. Or some cities, they say, oh, we don't have a climate problem. If it's raining very, very heavily, it doesn't give any problems in our city. Or they say it costs too much money. So we wanted to show that this is not really true, that it doesn't cost too much money, and we want to show that's easily possible. Now, the approach we used is that we defined characteristic topologies of neighborhoods, of urban areas, and we wanted to show for each of those neighborhoods, how can you design it in the traditional way, how would you do it in the traditional way, and how would you design the street in a climate resilient way. We did focus on urban flooding, pluvial flooding, but later on we also did research on heat stress and how you can design in this way. And what we did is we designed it and we calculated the cost and the benefits. Something more on these topologies. Of course, you know, the city is not the same everywhere in your country. And in the Netherlands, for example, we have about 10 different topologies of urban areas. Like from the 1900s, they started up, especially in large cities, they started up building very densely, like this picture on the left. Does it work? Yeah, this works. And later on, they started to build high-rise buildings, like here. And even later, they started to provide more green in the area, more living areas with streets where no cars are standing. So those are very different, and you can imagine that those different topologies also behave differently at a very extreme rain event. So I'll show you some examples. So this is the pre-war closed block, and as you can see from the picture set in, it's very stony, little green, only trees, and you can imagine the water can hardly go anywhere. And this, the high-rise buildings, the living area, and here you have plenty of space for maybe storing water. There's plenty general or common urban areas. Another example is the community neighborhood. In fact, we call them cauliflower neighborhoods because of the shape. So, and here you see more green in the urban area. So the question is, one more, okay. This is we call the garden village, and even more green. So, and then the approach is how can we design this in a standard and a traditional way. Now in the Netherlands we have, for a large part, a flat country, and therefore we have made more or less the design that more or less 20 millimeters in an hour rainfall can be stored and discharged by the sewer system, and if there's more rainfall, then we even don't look what's happening. That was before 5 years ago. And now slowly we're starting to think about what will happen if there's a more heavy rainfall event. And this 20 millimeters in 1 hour is happening every once in 2 years, and maybe it will become once in 1 year because of climate change, but okay, that's the idea. Okay, so the traditional design is providing water for 20 millimeters and hoping for the best for the rest. So that's not very climate proof. So we defined a new climate-proof design, and in this research, that's too quickly. Can this go back? Yes. Research, we thought, okay, the once in 100 years, once in a lifetime event, for example, once in 100 years might be a good example of how much rainfall might be important for a city. And there were many discussions within the group. Would it be 60 millimeters, or should it be 90, or should it be 40? We did some research, again the wrong button. We did some research on what was given by the meteorologists, and we said, okay, 60 millimeters in 1 hour might be a good number, but it's not really said this is the real number. And okay, we made a design for preventing flooding at 60 millimeters in one hour. And for the rest, we looked at a design with a combined sewer system and one without any stormwater system. So we made 4 designs, the standard situation with a combined sewer system, and then 3 others. I will go into this. And then, of course, we estimated the cost and benefits. Okay, it's a bit boring. You just calculate how many pipes, how many stones, how many curbstones, everything, and you do something about an estimation of the damage due to costs. And so we can calculate it in many ways. Okay, we assumed some things, and I'm confident it was good enough. And so we have costs and benefits of this, of the different designs. And later on, we also estimated the value, the benefits of green measures. So we have 2 examples. The first one is this pre-war closed building block, densely built up, and standard situation would be this. And now, if there would be heavy rainfall with more, like once in 20, once in 40 years, then the water would simply just go over the curbstones and go into the houses. But we said, okay, the climate-proof situation would be one in which the street level would be a bit lower. You can see it going down. And at the same time, I put in the amount of water which would be there at this extreme event, the 100 years event. And you see the water can doesn't reach the houses here. So we designed it in such a way by lowering the street that there was no flooding. And in this case, we have here still, it's a separate sewer. Okay, it doesn't matter. That's a rainwater sewer at least. And for another design, but then without a rainwater sewer, we made it with some infiltration trenches along the road. And a third one, we made it with pervious pavement in the road and some infiltration material, bringing it into the ground. So we made several designs, and we compared them how much they would cost, and we already compared how they function. So the climate-proof designs functioning well, and the other ones might have flooding. So here's a comparison of the costs. You see in red the damage costs, so there's only damage in the traditional design, a very small one in the climate-proof designs. There are maintenance costs and a construction cost. And what we did is we calculated all the costs for building, for taking out, for rebuilding during 100 years. And we added them, or we calculated the net value. So you see that all of them cost almost the same amount of money. And because of all the uncertainties, we say this can be climate-proof for the same amount of money. It doesn't really matter if one is really more expensive than the other one. They are almost in the same range. This one seems a bit cheaper, this with the rainwater sewer, than those two. But also this might develop more, and like we had this morning, if there's more done on a pervious pavement, maybe the pervious pavement will get much cheaper in the future. So we did this for this example, and because of the time I don't show all the other examples, but we did it for 6 examples here. These are for flat areas and also for some sloping areas. But for the flat areas, we always saw that the cost for climate proofing was almost about 100% if you amount the maintenance and the building costs. So we concluded in the Netherlands we can retrofit the urban area, living urban area, in a climate-proof way for the same amount of money. So I think that's a very important message, and this would help the municipalities to do this. So that's why we wrote it in the book, and that's why we try to convince the municipalities to start looking at this. They don't really have to do it in this way, but they can use this as to be more enthusiastic about the subject. And there's one thing, the topologies, they give more insight in the possibilities, both for flooding and heat stress, which I didn't show here. But therefore, we wanted to find out what were the topologies in the whole of the Netherlands, and we did a project to define for every building up area in the Netherlands the topology. So that we did it in GIS. So we came, this is Amsterdam, but you see it all over the Netherlands. We have maps with, in different colors, the different topologies. And for example, this green area is more or less high-rise. And you say, okay, if this is this area, you can look for this kind of solutions to solve your problems. I think I'm just in time with my last sheet. This was my presentation. I thank you for all the attention. I want you to have questions for me, but I also have 2 questions. Do you think it's useful to apply such kind of topologies in other European countries? And maybe we can cooperate on this. And what do you think of the design rainfall?
Thank you, Jeroen. Well, the roads are a very important part of the public infrastructure. Are there any questions from the audience? Yes, please. The microphone, please.
I think it's on. Yes, it's on. Okay. Richard Ashley. Thank you for that, Jeroen. I'm also speaking on behalf of another Dutch study, which we did at IHE Delft, primarily led by another Jeroen Reicher. I'm sure you're familiar with him.
Yes.
And what we've looked at, and this was part of the CRC for water-sensitive cities in Australia, would you believe, but we were looking at what we call mainstreaming, which is piggybacking on normal infrastructure changes to bring in climate proofing and flood and drought proofing. And we looked at 12 case studies, none of which succeeded in mainstreaming, because always the roads people didn't want it, or the other infrastructure providers couldn't factor it into their program. We have produced a typology methodology for doing this, which is available on the CRC for Water Sensitive Cities website, if anybody's interested, for mainstreaming. But it is very difficult to get implemented. We found the costs were higher, always. So, have you any experience of the mainstreaming concept? I'm sure you do. And how we could, as a community, try to influence the people who always cause us trouble, mainly the highway engineers.
I know this problem, and also I'm working at a private consultancy, and I'm always dealing with this. So there's one engineer or water engineer or a climate change engineer, and he or she wants to change, and other parts in the municipality, they just don't want, or they see the amount of cost coming for changes. But I think this is one way to help. The other way is also doing workshops and helping there. I think that will be also in the mainstreaming. You will have to show, people have to learn themselves that doing it differently is possible. And I still believe the figures we put in here are correct. So if you look at over 100 years, you showed it doesn't cost anything more. But if you look at one project, then you say, okay, we had to hire so many advisors and we have to spend so much time on this, and then it will be more expensive. But I think there's more work to be done. And Jeroen Reicher is now also professor at the University of Applied Science, so I will work with him. So,
okay, thank you very much. I think the public infrastructure, I'm sorry, the time is out, so if you have any questions, please contact Jeroen.
I'll be here a whole week. So.
Well, I would like to invite the next speaker, which is Daniel Dagenet from the